Okay, guys, so sorry we ran out of time during class, but one of the main ideas that I wanted you guys to understand about the lesson is that when you have a piece of paper or cardboard or material, a flat piece of paper, and you're trying to create an open top box from it, you have to cut out little boxes from the corners, okay? So think about the problem that was 19 inches by 26 inches on the front page of the notes, right? Essentially, we're cutting out little boxes from each of the corner that have a length of x, right? It's an x by x, or that's like the length on each side, x and x. You're cutting those out to create the biggest box possible that holds the most amount of volume, okay? Now, realistically, there's only so much paper or cardboard. You know, there's only so much material you can cut out before you run out. So whenever you are asked for the realistic domain, it's asking you how much can you really cut out from that material. And at most, you can cut out less than half of the middle, okay? So give me 1 second, less than half of the shorter side is what I meant to say. So if you look at this example, right, the shorter side was 19. Half of that is 9.5. So x has to be less than, not equal to 9.5. Because if I put 9.5 into my equation and I put the 19 as my length and 26 as my width and I type it into this equation, if I put 9.5, it's going to give me a volume of 0. That means the box isn't going to hold anything. So the domain, the realistic domain, or the length of that little cutout corner that you do, has to be less than 9.5, which is half of the shorter side. Half of the shorter side. Okay? Okay, so for this next section, we have a piece of paper that's 11 by 17 centimeters, and they want to create an open top box. They're asking, what is the height of the box so that we maximize the volume? So notice that the word max is in maximize. We're talking about height of the box. The height of the box is always the x value. That's also the length and width of the square that you're cutting out from the corners. Okay. All right. Now, if you type this into your graphing calculator, so go to y equals. Also, you need to make sure that your stat plot is turned off since we're not putting in any data. Okay. So you need to make sure that your stat plot is turned off. Then go to y equals and you type in your equation. So in this case, the shortest side or the length is 11 centimeters. So your equation is going to be 11 minus 2x close parentheses. Then in a new parentheses, the width, which is 17, minus 2x, and then times x. So remember, this is an adjusted equation for the volume of an open top box. Okay, so you can push zoom stat to see the graph. You don't have to worry about adjusting your window if you don't have to. This is perfectly fine. You can leave it like that. And now we're going to go to second trace and look for maximum. Remember, you need to hover your cursor a little to the left of the maximum point, and then hover your cursor a little bit past the max, so a little to the right of it, and then push enter one more time. So essentially, you're pushing enter 3 times. So the maximum length of that little cutout square is the height of the box. So the 2.178 centimeters is the max height of the box to maximize the volume of 182.967. So the height of the box is 2.178 centimeters. The y value is 182.967 centimeters cubed. Remember, volume has units cubed. So this is the height of the box, and this is the volume. Notice they asked for the height of the box, so the correct answer is 2.178 centimeters. Number 2 can be done in exactly the same way. Number 3 is asking you what is the size of the square cutout. That is exactly the same exact question as what is the height of the box. Okay, so think about it over here. The height of the box matches the cutout in the little squares that we're cutting. Okay, the height of the box is X, and so is the length of the square you're cutting out. Realistic domain, remember, is half of the shorter side. So X has to be less than half of the shorter side. All right, hopefully this is enough of a hint to help you guys finish the notes. And we'll talk about them in class if you have questions. Good luck.